Hello everyone. My name is Pradeep Sawlani. I'm an engineering manager focused on simplifying authentication for Anthos customers.
My name is Richard Liu, and I'm a product manager focused on streamlining the user experience for authentication for Anthos customers. Authentication is complex. Passwords have progressed to keys, certificates, and multi-factor auth. Basic authentication has shifted to advanced, more secure protocols such as Kerberos, LDAP, SAML, and OAuth. Single-tenant monolithic applications have evolved to multi-tenant containerized applications distributed across hybrid and multi-cloud environments. It's clear that authentication has become increasingly complex, yet more than ever critical to get right. Ensuring a secure and integrated authentication experience requires both time and expertise. This leads to onboarding friction as enterprises shift workloads to containers in the cloud, causing delays in modernization plans. On the other hand, security risks have far greater implications. Multiple authentication solutions, for example, maintaining certificates alongside protocols such as OIDC, may increase the chance of security breaches, and improper access control can lead to misconfigurations and vulnerabilities. In fact, in a recent survey, 78% of organizations cite security, not cost, as top priority when deploying identity solutions. What's the end result? Administrators spend excessive time on deploying authentication solutions and preventing misconfigurations in their environment. The complexity is taken further with hybrid and multi cloud environments. As enterprises modernize their applications and adopt solutions such as Anthos, they'll be faced with the fragmented identity challenge across multiple environments. Each environment is built on a different identity store. For example, Active Directory for on prem, Cloud Identity for Google Cloud, and IAM for AWS and Azure. Many of these environments may use the same identity provider or maintain a bespoke identity solution. For example, we have some groups in other clouds using IAM accounts, users in on-prem using both Okta and Active Directory, and users in other clouds connecting to Active Directory. Mergers and acquisitions add to the complexity. In addition to employee identity, customers also need to manage partner, end user, and workload identity. Essentially, the identity solution is a mess. So, how do we enable customers to manage their clusters across multiple environments, each with a different identity provider and protocol? During this session, we'll walk through two separate workflows: users authenticating to the Anthos control plane, and workloads running on Anthos clusters accessing GCP APIs and services. Let's start with user authentication. Meet Charlie, who's a platform administrator. Charlie manages a cross functional team of developers focused on building and maintaining IT platforms within their organization. Charlie's team maintains two separate environments: GKE on prem and GKE on AWS. He needs to ensure his team has proper and secure access to the Kubernetes API server to perform management and troubleshooting tasks. Charlie is faced with highly complex identity requirements. His organization has already started modernization efforts by shifting on prem workloads to containers, which operate around the clock to support both internal and customer facing applications. Within his team, Alex is a developer working on their internal HR application and is provisioned within Active Directory on premises. Alex needs administrative access to GKE on prem clusters to perform management tasks. With the recent acquisition of a startup, Charlie's company brought in developers such as Blake that are maintaining projects on AWS with identities stored in Okta. Blake needs access to a customer facing SaaS application to perform troubleshooting on GKE on AWS clusters. And there's other employees maintained in different identity solutions that further add to the complexity. So, how do administrators such as Charlie manage such complex identity environment? Let's take a look at some options. What are some options for identity? Charlie can use Kubernetes identity starting with client certificates. However, this is insecure due to the need to maintain private keys that are typically handled on insecure media. Anyone with access to these repositories may gain unwarranted access to the cluster. Charlie may also opt for basic auth, but that's mostly limited to test and dev environments since credentials never expire and passwords cannot change without restarting the API server. There are also service account tokens, which present risks as well with users that access secrets and can authenticate as a service account. We recommend OpenID Connect, or OIDC for short, given the short-lived and refresh tokens, but it's not available for every environment. Where is it currently available for Anthos? Let's start with on-prem. Customers can already leverage external OIDC identity providers, such as ADFS, to authenticate to GKE on-prem clusters. We currently have GA support for OIDC and alpha support for LDAP for GKE on-prem. We've also recently launched beta for OIDC access to GKE on AWS clusters, and are looking to add support for GKE on GCP in the future. Traditionally, Google Cloud has offered a synchronization-based identity model, requiring you to synchronize identities with Google Cloud. While this may work for certain scenarios, there may be concerns around consistency and latency for a hybrid or multi-cloud deployment. With Anthos, we want to meet you where you are and enable you to use third-party identity providers and authentication protocols. You no longer need to synchronize identities with Google Cloud or worry about consistency across environments. We want to save you time and reduce friction during the onboarding process. Let's take a look at how this will work with a demo starting with GKE on-prem. This demo will walk through 3 user journeys. Charlie will configure an OIDC identity provider, Active Directory Federation Services, also known as ADFS, for his team to authenticate to a GKE on-prem cluster. Alex will authenticate using the gcloud CLI without requiring a cloud identity account with the gcloud Anthos auth login command. Alex will also authenticate from the Cloud Console. While this demo focuses only on GKE on-prem, the user experience will be the same for any Anthos cluster, including Anthos on AWS. Before getting started, Charlie needs to perform a few steps to enable OIDC authentication. He'll need to reach out to his organization administrator, who manages Active Directory domain services, and provision an additional server for ADFS, which enables OIDC support. As you can see, Alex and Blake are provisioned as users in the ADFS instance and members of the same group, platform developers. The administrator registers an OIDC client in ADFS with 2 redirect URLs, one for Cloud Console and one for gcloud CLI. The administrator may customize claims to include group membership information and tokens for use with Kubernetes RBAC policies. The administrator provides Charlie with OIDC client details, and Charlie proceeds to create an Anthos cluster and configure OIDC in the user cluster configuration file on an admin workstation. Let's take a look at this file. There are a few fields that are important for OIDC. The issuer URL, or the URL of ADFS, is used by the Kubernetes API server to discover public keys for verifying tokens. The client ID is the client application ID used to make authentication requests to ADFS. The client secret is used by the gcloud CLI and Cloud Console to exchange authentication codes for an ID token. The username and group specifies claims in the ID token to use as username and groups. There are a few other fields such as scopes, extra params, and CA path that can be specified based on your configuration and identity provider. Deploy Cloud Console proxy should be set to true if your OpenID provider is not reachable over the public internet. This deploys a reverse proxy in the Kubernetes cluster. After creating a user cluster with this configuration, Charlie can create Kubernetes RBAC policies, allowing the platform developer group in Active Directory to view pods in all namespaces. He can create a cluster role and cluster role binding. Charlie needs to create a login configuration file containing details about one or more clusters and provide each file to developers who want to authenticate. You can do this using the command gke control create login config and pass in the kubeconfig for the user cluster. Let's try it out. By default, this creates a config file called kubecontrol anthos config.yaml. Let's take a look at this file. This configuration file contains the OIDC information provided during cluster creation, as well as information about the Kubernetes API server. The file can be distributed to Alex and used to log into clusters. Alex and Blake can access this file distributed through a secure URL and stored in a well-known path. Once Alex has access to a login configuration file, Alex can log into clusters to perform kube control commands. Alex can log in using the gcloud CLI or Cloud Console. The CLI experience starts with kubectl Anthos config file with several cluster definitions containing information about the identity provider and OIDC. There are two clusters available, one of which is configured with ADFS for GKE on-prem. Alex can access the API server using the gcloud CLI with the gcloud Anthos auth command. Google Cloud Identity credentials are not required, and the component can be installed simply by running gcloud components install and updating to the latest gcloud version. The input is a kubectl Anthos config login configuration, and the output is a kubeconfig, which will be used by kubectl to send requests to the Kubernetes API server containing ID and refresh tokens. This will create a local kubeconfig in the current directory. Let's run gcloud Anthos auth login to log in. If Alex does not pass in the list of clusters, the command will exit and print the available options and request the user to specify the cluster they want to log into. Let's log into the ADFS cluster. It's the same command as before, except now we pass in a cluster argument specifying the cluster name. We'll perform an OpenID credential exchange, starting a connection to the IDP to allow Alex to log in. The IDP will return an authorization code, which we will take and send to the IDP and get an ID and refresh token. These tokens are written to a kubeconfig file used by kubectl. We have a user account under Alex's name, and we've made it part of a group that is defined in Active Directory under Platform Developer. We've created RBACs and applied them to our API server. You can see a kubeconfig file has been generated, so let's take a quick look at what this kubeconfig file contains. As you can see, we have a kubeconfig generated with the ID and refresh token generated for our user. If we run a command using kubectl and the kubeconfig to get pods, it'll return a list of the running pods on the cluster. So let's try that. So let's take a look at now how Alex can authenticate using the Cloud Console. Alex can navigate to the cluster section in Cloud Console and look at a list of available clusters to log in. We previously logged into ADFS to GK on-prem. Now let's try Okta with AWS. So let's click on Login and see there's three available login options: Token, Basic Auth, and Authenticate using the external identity provider. So let's try the third one. This redirects us to an Okta login page where we can log in. And as you can see, Alex has successfully logged in to the cluster running on AWS. We currently support OIDC authentication with third-party identity providers for GKE on-prem and AWS. In the future, we'll add support for additional environments such as GCP and other clouds.
As you just saw in the demo, Charlie's organization administrator uses ADFS with Active Directory. Provisioning ADFS adds to the onboarding friction as organization administrator may have resource or funding constraints. Or maybe because of compliance reasons, provisioning ADFS may not be even an option. In addition, there may be a hidden cost associated with managing and maintaining an ADFS server. What if Anthos supports authentication with Active Directory using LDAP or Kerberos instead of provisioning ADFS? Let's see how that works with the demo. In this demo, we will walk through how to configure LDAP with Anthos GKE on-prem cluster. LDAP support is added in Anthos 1.4.1 and is in alpha state. It is assumed Charlie has created an admin workstation and admin cluster and has reached out to the organization administrator for LDAP configuration. Charlie creates user cluster configuration using gke command line tool. For our demo, we have pre-filled configuration specific to our environment which we will be using. Let's take a look at the user cluster configuration file. We have named our cluster as GKE on-prem LDAP. All fields related to authentication are under authentication anchor. As Charlie is not using ADFS, the OIDC section is kept disabled. If needed, OIDC and LDAP can be enabled simultaneously. The LDAP section is enabled under LDAP anchor. The name represents the human readable name of the LDAP server. The host
This field is provided by organization administrator and is typically the IP address or the host name for Active Directory domain name services. At Alpha, we only support simple LDAP connection type. Support for Start TLS and LDAP-S would be added in the future. The base DN represents where user entry exists in the Active Directory. The user attribute is the name of the attribute which precedes the username in non-DN. Only supported value at alpha is CN, which represents common name. Member attribute is the name of the attribute which records a user group membership. For Active Directory, this is typically member of attribute. After filling in all configuration fields, Charlie creates a user cluster GKE on-prem LDAP using GKE Gutle tool. This step will take some time to complete. Once user cluster is created, you can check if LDAP is configured correctly by checking status of Anthos Identity service. Charlie creates RBAC policy to allow users in the Active Directory security group platform developers view various Kubernetes resources. As you can see, the group over here represents the Active Directory security group platform developers. Charlie then generates a login configuration for the cluster using GKE Gutle command line tool. Charlie then proceeds to share this login configuration with Alex. Alex installs gcloud SDK and uses gcloud Anthos auth login command to get kubeconfig for user cluster. Note, the argument to the login config is, is the file which was shared by Charlie. Since we are logging into an AD server, we'll select option 1. This is the username in the LDAP and the corresponding password. Once successful, this command will generate an kubeconfig for Alex to use. As Alex is member of Platform Developers Group, Alex should be able to view Kubernetes resources. Let's check that out with kubectl command. This completes our demo on how LDAP can be used with GKE on-prem clusters.
Let's take a look at how everything fits together. On the front end, Alex can authenticate using CLI with gcloud Anthos auth login or Cloud Console by navigating to the login button. On the back end, we have a service running in the cluster called Anthos Identity Service, which is configured as a webhook token authenticator. This service enables support for different authentication protocols such as OIDC and LDAP. The front end works alongside the back end by acquiring tokens from the identity provider, generating a kubeconfig file with the appropriate format for the backend to consume. In the future, we will be adding support for additional authentication protocols in Anthos Identity Service. We have spent some time talking about user authentication to Anthos GKE clusters. But what about workloads running on Anthos clusters? Kubernetes workloads aren't self contained. They often need to authenticate to services outside a cluster. For example, Charlie's teams may have a workload that need access to a GCS bucket. How can you best secure workload accessing a GCP API and services? Let's take a closer look. Today, you can use service account keys and store them as secrets. Workload can use these secrets to access GCS bucket, but these secrets are difficult to deploy, audit, and manage. What if each workload could use its built-in Kubernetes native identity, data Kubernetes service account to authenticate to GCP? Workload identity for GKE enables Kubernetes workloads hosted on any cluster to authenticate to Google Cloud in a consistent way without the use of service account keys. This currently works for GKE on GCP and will expand to other environments like AWS or on prem in the future. Let's see it in action.
In this demo, we will walk through how to enable workload identity on Anthos cluster on GCP and use workload identity to access Google Cloud API without downloading service account key. First, Charlie creates an Anthos cluster on GCP with workload identity enabled with gcloud command line tool. Note: the argument to workload pool option has to be of format project ID followed by suffix svc.id.go. In Charlie's case, project ID is on-prem IDP test. This step would take couple of minutes to complete. After creating a cluster with workload identity, Charlie creates Google Service account which will be used to access GCS bucket. Charlie configures IAM policy to allow service account GSA app1 to access the bucket app1 artifacts using gsutil command line tool. Next, Charlie configures kubectl to access the Anthos cluster. Next, Charlie creates namespace for the workload called app1. Every namespace in Kubernetes has a corresponding default Kubernetes service account associated with it. Charlie creates an IAM policy binding to allow default service account for namespace app1 to use Google Service Account GSA-app1. After this step, Charlie adds annotation to Kubernetes service account. Charlie now deploys sample workload in app1 namespace to verify if workload in app1 can access GCS bucket. In this case, the sample workload is gcloud SDK Slim. The above command should give us an interactive shell with Cloud SDK installed. Now Charlie will use gsutil command to view the bucket contents. This demonstrates pod uses Google Service accounts when calling Google Cloud API.
As you can see, Anthos Identity Service, along with Workload Identity, offers a seamless solution for managing authentication to multiple Anthos GKE environments, supporting user and workloads, and providing a seamless onboarding experience. As a result, You can get started quickly with the product that has built-in enterprise-grade security. You can save costs and streamline your identity configuration by leveraging existing identity providers. Authentication doesn't have to be complex or insecure. Simplify identity with Anthos Identity today. Thank you.